Have you ever just stared at your organization's data and felt, completely overwhelmed? You've got one system holding personal details, another system tracking finances, and maybe a completely separate third one managing departments. It's all there, but none of it is talking. So how do you actually merge massive, disconnected data silos without losing your mind? How do you get them to communicate so you can uncover the real insights hiding just beneath the surface? Well, let's figure out how to bridge those gaps.
Okay, let's dive into this explainer on the fundamentals of SQL table joins. Honestly, joins are arguably the absolute most powerful tool in your entire data toolkit. They're the essential bridges that let us take those fragmented pieces of information and build a complete, comprehensive picture. If you want to transform raw data into actual knowledge, you have to understand joins. Here's a quick roadmap of our technical journey today. We'll start with connecting your data, move into the inner join match, and then cleaning up with aliases. From there, we'll tackle outer joins and nulls, joining tables to themselves, and finally, bringing it all together. All right, section 1, connecting your data. Let's establish a rock-solid baseline here. At its core, a join is really just a method that allows us to combine two or more tables together. But there is one absolute requirement. They must have a common column. Think of this common column as a bridge. The names of the two tables you're connecting might be completely different. Sometimes even the column names themselves might differ. But the actual contents inside that connecting column, the data itself, must align. To really ground this, let's use a real-world analogy. Imagine you're standing in an HR office with two physical filing cabinets. Cabinet A holds the employee demographics, folders with personal details, ages, and occupations. Cabinet B is the employee's salary cabinet, which has all the paycheck information. Now, to get a complete picture of an employee, you need to physically pull a file from Cabinet A, pull the corresponding file from Cabinet B, and staple them together. But how do you know which files to staple? You use the bridge. You look at the shared employee ID written on both files. That is exactly what a SQL join does digitally. Moving on to section 2, the inner join match. Let's talk about strict matching rules. If you simply type the word join in SQL, the system automatically defaults to an inner join. And here's how that logic flows step by step. First, SQL looks at both the demographics and salary tables. Second, it scans down the lists to find rows where that shared bridge, the employee ID, is an exact match. And third, it returns only the rows that exist in both tables. It strictly requires a match in both filing cabinets to pull the data. If a file exists in one cabinet but not the other, the inner join ignores it entirely. But here is the wild part. That strict rule creates a literal ghost in our system. If we run an inner join on our source data, employee ID 2 is completely missing from the results. No trace of them. Why? Because employee ID 2 exists in the salary table, but for whatever reason, they don't have a file in the demographics table. Because there wasn't a perfect match in both cabinets, the inner join just drops them from the final report completely. They vanish. We'll figure out how to find that ghost in a minute, but first, let's talk about formatting. Section 3, cleaning up with aliases, because we definitely want cleaner code. And this brilliantly illustrates a super common coding trap. When you join tables that share the exact same column name, you can't just say on employee ID equals employee ID. SQL has no idea which table's ID you're talking about, and it's going to throw an error. Now, on the left, you see the bulky, error-free way to do it, writing out the full table names. It works, but it's tedious. But on the right, we use aliasing. By assigning dem to demographics and sal to salary right up in the from clause, we create this sleek, beautiful syntax on dem.employeeid equals sal.employeeid. It makes your code incredibly clean and so much easier to read. Which brings us to section 4, outer joins and nulls. How do we handle the missing pieces of our puzzle? Remember how the inner join demanded a perfect match? Well, outer joins play by totally different rules. They actually force the system to grab a file from one cabinet, even if the other cabinet has absolutely nothing to staple it to. A left outer join will take every single row from the first table you write down, the left one, and only bring in matching data from the right. A right outer join does the exact opposite. It demands every row from the second table, matches what it can from the left, and this is key, it returns a null for any missing data. Now, what's really interesting about this slide is seeing exactly what happens in our right join results. Because we made the salary table our right table, we asked SQL for every single salary. And look, employee 2 reappears with their $65,000 salary. But since they still don't exist in the demographics table, we get these loud, highly visible null values under first name and last name. The missing data is forced right into the open.
So the absolutely crucial point here is that you should never ever fear a null value. These nulls aren't errors in your code, they're a visual reality check. They highlight crucial gaps in your organization's data integrity. Seeing that null tells HR immediately, hey, someone is getting paid, but their personal paperwork was never filed. Outer joins and the nulls they produce tell a powerful story of missing data.
All right, Section 5, joining tables to themselves. This is the self-join.
Now, a self-join is literally exactly what it sounds like, joining a table to a copy of itself. The source material beautifully demonstrates this using a secret Santa assignment. Imagine taking the salary table, aliasing it as emp1, and taking a second copy of it, aliasing it as emp2. If you join them on the condition that emp1's employee ID plus 1 equals emp2's employee ID, you're effectively shifting the whole table by 1. So employee 1 gets matched to employee 2 gets matched to employee 3. It's this clever sequential loop created simply by joining a table to itself using basic math.
Let's move to and see how this all builds in our final section. Section 6, bringing it all together. Because here's the thing, you aren't limited to just 2 filing cabinets. Once you join 2 tables, you create a new, wider combined table. And you can then immediately join a 3rd table to that new result. In our source example, we first inner join the demographics and salary tables using the employee ID bridge. Then, literally in the very next line of code, we add another join to link the Parks Departments table using the department ID as our new bridge. You're sequentially stapling a 3rd file to your stack. This multi-table mastery means this stapling process can extend to as many filing cabinets as your organization has.
So, by mastering inner joins to find perfect matches, outer joins to expose the missing pieces with nulls, and clean aliasing to keep your code readable, you literally hold the keys to your data kingdom. I want to leave you with this final thought. If a simple join bridges 2 data silos, what hidden insights, what massive efficiencies could you uncover by linking every disconnected table in your organization? The tools to find out are right there in SQL. Get out there and start connecting the dots. Thanks for joining me on this explainer.